Welcome to AmiBo's third video. Hopefully we're managing to live stream on YouTube. And you're of course highly welcome if you're part of the majority who'll be watching this after the event. So yeah, please, if you're part of that set, do ask any questions in the comments and we'll respond as soon as we can. So today we're going to be building my first Pioreactor, and I have the perfect live guest to both help with that and to answer all of our questions on bioreactors. So why we need it? We need bioreactors basically to research how to produce sustainable protein, because livestock burp methane, which is 80 times worse than carbon dioxide, and their dung and urine emits nitrous oxide, which is 273 times worse than carbon dioxide, to say nothing of the impact that it has on water quality. On top of that, the land lost to livestock is a massive environmental issue. So we want to develop open source methods for anyone to ferment tasty, nutritious protein from sunlight and air. Our first video explained the reasoning, and last week we unboxed my Pioreactor and discussed why Garrett and I had independently picked Pioreactor for research work over all the other brands of open source bioreactor. Then we went through Garrett's initial results with his pair of bioreactors, and in this video I'm finally going to build my own bioreactor. So yeah, I'm Martin Curry, and it's a huge privilege for me to introduce the amazing Cameron Davidson-Pilon. Did I get that right, Cameron?
Yes, that's perfect.
We had some confusion earlier, but anyway, we're good.
Yeah.
So yeah, Cameron's founder and CEO of Pioreactor. How are you doing today?
I'm great. I'm great. Thanks for inviting me.
Brilliant, great to have you here. And where are you today?
I'm in Waterloo, Canada, which is just outside Toronto, Canada.
Cool. What's the weather like?
Cold. It's like we just had our first frost last night, so it's like near 0 Celsius. It's cold here. Yeah.
Right. It's cold here as well, which is actually the main reason that I'm wearing the lab coat, because you wouldn't let me wear a woolen jumper according to
That's
the,
right.
the recommendations.
Yeah.
Yeah. So yeah, if anyone has any questions or comments, if you're watching live, please do pop them in the live chat. Or if you're not live, then in the comments, that'd be great. I think we can see stuff arrive in the live chat, whereas we might not see it if it's in the comments while we're going live. Yeah, but Cam, if you could keep your eye on that, that'd be brilliant, and just interrupt me if anyone asks anything.
Will do.
So yeah, let's crack on, I think, with the construction. So yeah, there are detailed instructions on how to set up your bioreactor at docs.pioreactor.com, but I'm not much of a reader. I did plan to read through it today, and then all sorts of stuff happened. The table broke, numerous things. So I haven't got round to that. So yeah, Cam, could you help me set this up, just sort of step by step?
Sure. Yeah, I sure can. Our instructions are fully available, but you're going to get the personalized all the tips and tricks from the engineer in charge of this.
Yeah, this costs a lot extra. And sorry, not the, if you want this service, I mean, but yes, this screwdriver as well is just proof that I have been on the website. I did look. It is the very one, yeah, that we saw in your pictures.
There it is. Yeah, yeah.
And speaking of my woolly jumpers, I'm going. Everything's been going wrong today, so I'm gonna attach myself to this as well, which will probably cause further problems. But anyway, so what do I do first?
First, you'll grab your bottom faceplate. I'm going to assemble one with you, kind of
Oh,
show
cool.
me. So, yeah, so grab your bottom faceplate.
Yep.
First, we're going to note the orientation. This indent here, note that. Note the indent in the middle as well.
Yep.
So we'll grab this, and we're going to put 4 of the 10 millimeter screws through the bottom.
Those are the longest ones.
They are the longest ones,
Yeah.
yes. Yeah. So they're going to kind of go in like this. You put 4 in each corner.
Cool. Cool.
And then on top, on the other side of that faceplate, on the top side, you'll put in a hex nut. attach a hex nut to each of those screws.
Okay.
Okay.
Right, so that's going to take me a little while, so I'm thinking I should probably keep things a bit more exciting and see if I can build this, live produce the video, which I'm kind of failing on already, and simultaneously give you a good grilling on some of your
Sure.
design considerations. So yeah, the wish list that we had at Amy Bow in the docs, the first point, it was the ability, in fact I really need to do this at the same time, don't I? So it was the ability for us to upload our data into a cloud so that we can do stuff like basically have people who don't have so we can live stream. That would be nice. So it'd be good if we could get the data out live, so if somebody's doing an experiment, people can actually see the data as it comes out. But then also for those who don't have back labs, they can interrogate the data, mine what would hopefully become a massive data set, and hopefully build digital twins, which could I think really help us streamline the research.
Yeah,
What are
we
your thoughts on that?
yeah we designed the Pioreactor on the Raspberry Pi, which allows us to do like a lot of really interesting I/O, both like in terms of hardware I/O, but also software I/O. The Raspberry Pi, if you just write the right Python program, can really easily ping a external database or a cloud database or any kind of external API, really. So it's not that hard. We internally to the Pioreactor is a data streaming service that you can kind of hook into and listen to. And when you hear something, maybe it's like a temperature reading or an optical density reading, you can fire that off to an external cloud database. Not a problem.
Do I need to screw these in?
How do you screw them in? You just with your hand.
No, so just hand tight.
Oh. Yeah, hand tight.
Yep, cool. Great.
Cool. So that's finished there. Nice. Looks great. So the next step is to take your Raspberry Pi. I have a Pi 0 here, 0W. You have a 4.
Yep.
Any Pi model works, including the new 5.
Brilliant.
So take your Raspberry Pi and you sort of you stick it onto the screws. Again, noting the GPIO pins, these 40 pins, they should align with that indent on the bottom. So it should look
like that.
Yeah, just do a 180 for me. Flip that over. Yeah, looks great. Okay.
Cool.
The next step is to take the larger hex nuts. I think these are
the ones that have screws on them.
No, with with screws. Yeah, I have to consult my own instructions. With screws.
Cool.
So these guys, all the measurements are on the label too, and then you screw those onto the exposed 10mm screws on the corners.
Cool. Right. So the second thing on our wish list, while I tighten this up, was larger vessels. So like if I was doing spirulina, for example, it would be really good to be able to monitor the pH, which I think is going to be difficult in a tiny vessel.
Yeah, that's right. We started off with the 20 milliliter volume vial because it was pretty simple, and for what we wanted to do, that achieved it. We were happy with that. We weren't expecting people to build like a feeding system off of this, but sure, maybe you could. So we do have plans to have product lines for larger volume sizes. We're looking at like a 40 mil right now. We're looking at a 250 mil right now. Maybe in the future, even larger than that. So we love the idea. We want like large product lines and having an ecosystem where an accessory that works for the 40 mil works for the 250 mil and the 20 mil and so on. Software is the same. The UI is the same. So it's just like this easy plug and play system. Cool. That looks really good.
And on the larger things as well, I should say that sort of long term, I mean, these are perfect for research, and that's what we want at the moment. What we need to be doing is research. Long term, the aim will be to get as large volume and as low cost as possible, I think. And I presume the software would all work perfectly with that, even if you weren't making huge, cheap production bioreactors, right?
That's right.
Or would
Yeah.
it?
No, it should be
Cool.
seamless. Yeah.
Excellent.
So the
Right, I've got those
next,
on.
yeah. Sorry.
Yeah, I've got those on, I
Okay.
think.
So the next step is to grab your hat, the Raspberry Pi
Okay.
hat. I'm gonna grab one myself.
Cool. That's why I've got my blue thing on. Although the Raspberry Pi I could fry as well, I guess. Right. One hat.
So yeah, to note, I mean, you're wearing like a grounding device. Be careful with the hats. You don't want to touch the interior too much. You want to kind of touch the edges, the corners. That's best. And what you're gonna do is just put the hat on the pins, and keeping in mind those screws. And if it needs a bit of force to put on, which is normal, press on the corners. Use the corners to kind of press into the pins. And you want to push all the way down until you're touching the bottom of the screws of the.
I'm struggling.
So it should look.
What's wrong with mine? Has it caught on something? Or am I just a wimp? Probably the latter.
No, it's all right. Yeah, keep going. Just you can keep. I mean,
It's
it's
just not moving.
pressure.
So right, I got one side going in a little bit. I think it was, yeah. My nut on one. Almost there.
I can kind of talk about why we chose a Raspberry Pi.
Oh,
Um,
yeah. Why not an open source board?
Yeah. The Raspberry Pi isn't famously, it's not open source, but they do a lot for the open source community. They share as much as they can. Some of their chips they use are closed source though. But yeah, we thought about using our Arduino or a different like style of board, like a microcontroller board like that. But we liked the Raspberry Pi ecosystem. There's so much software available for it. There's so much like large community support for it. When we started the project, they were more accessible than they are now, like available to buy. There was like that Raspberry Pi shortage. It's gotten a lot better since then. And they're reasonably cheap. They're not that expensive. I think too, like getting people familiar with the Raspberry Pi is really valuable. You get the full Linux system, you get like support for Python or other programming languages. The Arduino, you have like the Arduino language, but it's less accessible. It's harder to kind of work with. You need to know about a lot more things than just a standard Raspberry Pi. So
yeah,
we like the
one,
idea.
One Arduino, and I've got a lot of Raspberry Pis. I much prefer them as well.
Yeah.
Cool.
And we could do more. Like we can set up web servers. We can set up APIs. It's just more freedom for developers and users. Okay, so that looks good. You're happy with that? It's on?
Yeah, it's on.
Cool, great.
Yeah. I
So
can
we're
see
gonna put
some
that
silver,
aside.
but we're going full length on those. So, yeah.
Yeah, looks fine.
Cool.
We'll put that aside for now, and we're going to move to your heater PCB.
Mm-hmm.
So we can take out all the parts there. We'll need each of those parts. Again, it's a PCB, so you don't want to touch the interior too much. You can touch the edges, that's fine. Okay, and I have to actually consult the instructions here because I forget myself. So we're going to take reverse that, flip that over. On the back side, that's just a bare aluminum side.
Mm-hmm.
We're going to use the thermal pad that we provided.
Mm-hmm.
It's like blue and gray thing.
Yep.
So specifically here, we'll remove the clear side, and there should be some like a light stickiness to it.
Mm-hmm.
and then put that onto the aluminum side. So the sticky side onto the aluminum side.
Okay. So we're not using the screws.
No,
Yeah.
no screws yet.
Cool.
Okay.
Okay.
And pat it, give it some pressure so it's, nice and snug there. And if you're happy, then you can remove the blue sticker on top.
Mm-hmm.
Cool. Okay. Now we can flip that over, and you'll note that there's connector, a beige connector.
Blue ends. Oh,
Yeah,
this bit. Okay. Yeah. I
yeah,
see what you mean.
that bit. So we can,
Yeah.
you can kind of see it's halfway done there now, but you can remove, or you can pull out the connector a little bit more. Yep,
Okay.
just like
Yeah.
that. Perfect. And I believe it's copper side up. Yeah. So yeah, stick that in there, copper side up. Put it all the way in, and then
Mm-hmm.
close the connector with your fingertips.
Okay.
Cool.
There we go.
Okay. So we're going to grab the vial holder next,
Mm-hmm.
and we're going to stick the, it's easier to say this in words or in pictures. We're going to stick that connector, the cord, into the hole, and it's going to come out the bottom. There's like a small notch in the bottom side. You can kind of see it there. Yes,
Yeah.
exactly.
It's done it.
Now, however, let me just look at it. Flip it over.
No.
Yes,
Yeah.
we've
Of course.
done
I've
around.
got it going the wrong way around. There we go.
Yep, and then you can use the cord to kind of pull it all the way through,
Mm-hmm.
and the PCB goes right at the bottom.
Yeah. Done. Now this bit gets me on to the next question. Our third point. I personally fancied a sort of easy open flappy bit here or something so that I could look, so we could close it and open it without having to use screws. So just wondering, yeah, why? I guess that's something we could do ourselves. Why did you do it with screws?
Yeah, the window there is like the plastic. We're gonna eventually put a plastic window over there with and secure it using screws. Kind of an artifact of an original intention or a current intention as well is the ability to put like more PCBs or more like sensors into the Pioreactor. So here I have this is actually a spectrometer from Adafruit. It's a 10-channel spectrometer. It measures
Oh,
between 415 and near IR actually. And there's
brilliant.
like a really bright white LED on it.
Yeah.
Anyways, this will fit onto the Pioreactors. You can kind of
Oh,
see it.
amazing.
So
Right.
we cure that with screws. Like you want that to be
Yeah.
very secure
Yeah.
because
Yeah.
you're doing measurements with it.
Yeah.
Um, so that was the original, like, oh, we love this idea of putting a
Mm.
spectrometer in it or any kind of PCB. We need to be secure though. We can't have it like moving around. So if you don't have a PCB, of course, you need something to cover it. So we chose
Yeah.
like a
Okay.
small plastic window, as we'll see.
Right. So can we use those now? The Adafruit.
Yeah, yeah.
Yeah.
So Adafruit sells these for I think $10 or $12 maybe.
$12 for wow.
Yeah,
That's brilliant.
USD. But yeah,
Yeah.
they're not very
Yeah.
expensive.
Amazing.
And it's a really good board. And so we have some data where we use this to measure like the color changes of cultures over
Mm.
time. And it's really interesting. It's a plug and play device too. You can kind of see. If I show this again, it plugs right into the hat. Oops, wrong way. There's a spot on the hat where it plugs in,
Right.
and it really is. It's just plug and play. There's some
Brilliant.
software, install, and that's it.
And does that come out then in the web interface? So the
It does.
reports that
Yeah.
we saw last week. Yeah. Yeah.
Yep.
Oh, that's amazing. Right. I'm getting one of those. Cool. Excellent. Yes. Much prefer that to an easy detach window. Cool.
Yeah. So we're not done with this yet. Holding the PCB so it doesn't move too much, we're going to screw in from the bottom using the 4mm screws, the tiniest screws. We're going to screw in from the bottom.
So that's right. Okay. Yeah. I've got two really little ones. Cool.
The other question we often get is, why did we put the Raspberry Pi underneath the wetware, the liquid, right?
I'm getting to that one. Yeah. But go for it. Yeah.
Yeah. Uh, it was a bit of like another design artifact. It used to be to the side, like kind of adjacent,
Hmm.
but there were a lot of wires going from like one area to the next area, and they were kind of disjoint. They were kind of like apart, and there were lots of wires, like too many wires. We didn't like the look of it,
How
so we
tight do I
thought,
do these?
hand tight, not too
Okay.
tight, but hand tight. Yeah,
It's not coming off anyway. Right.
yeah.
Cool.
No, it looks good. Um, so where are we next? Oh, so next step is we're going to take our stirring fan assembly
Hmm.
and we will.
So this is, I think, this is a really cool design. So basically, the fan is cooling, and at the same time we're stirring, right?
The fan is not cooling. You
The
could
fan's not okay. Right.
make some modifications to cool as well.
Right.
Yeah, there's actually like opportunities that we're looking at for this fan. We're thinking more about like uh, making the fan do something more than just stir.
Hmm.
The fan is like it's a fan, but it's actually just like a nice BLDC motor.
Right.
It's
Okay.
just a
Yeah.
very flat motor that spins.
Yeah.
Um,
Yeah.
so
Affordable way to get one of those then.
yeah, but you
Yeah.
could like there's ideas where like we cut holes in here and you can cool things down, but for the future perhaps. So what you want to do with these two items now is there's an arrow, if you'll
Hmm.
notice on the assembly.
Yep.
Yep. So position that pointing at the slot the cable's coming out of.
This one, like that.
Yes, that's right.
Yeah.
Yep. And it kind of fits into the four holes in the bottom,
Cool.
and then you'll screw in those holes there.
This is a nice screwdriver as well. I recommend them.
Yeah, they're really nice. Um, One question we got actually that we can answer. Do we have a list of Adafruit sensors that can be attached to the viewport?
I'm
And
managing to do this totally wrong. Right. I've got to start again, basically. Right. You need to hold
that's
this against. I've managed to screw them in, and it's just pushing this out of the way.
oh yeah. There's little nuts in the interior that you're
Yeah.
going to screw to. Yeah. Okay. So is there a list of sensors that can fit on the viewport?
Mm.
We don't have that available, but we should, because I mean, we want people to use that cool spectrometer.
Yeah.
Yeah, no, we will compile that list and share with the community, because yeah, that's something we should have. This is a very like pretty common form factor too for a lot of sensors.
Yeah.
We've seen other companies make sensors of this same form factor. So yeah, we'll compile a list and share it with others. Yeah, that looks right. That feels right, right?
Yeah.
Yeah.
Ah, dear. Right. So yeah, thanks for that question, Garrett. That's Did you mention the carbon dioxide sensor there?
I haven't, but it's a work in progress. So we're thinking about like a headspace sensor for the Pioreactor. Something you can measure the CO2 off gas of your culture, or if you're injecting CO2 into the culture, into the headspace, you want to be able to like record that as well. So yeah, that won't use this window. It'll use a different
Yeah.
window, but yeah.
Okay.
Okay, so we will do a check here, just to make sure that's all assembled correctly. So looking at what you've done, with a screwdriver, can you move the fan? Can you like sort of twist the fan and does it move freely, or is there any kind of friction?
A bit of resistance. In fact, there's quite a lot of resistance.
So what you can do is on the bottom, unscrew just a little bit. Unscrew each of the four,
Okay.
yeah, to add a bit more of a gap because you're probably the fan is probably touching the screws on the bottom.
Yeah, that's a lot for you
Okay,
now.
great. Okay. So next we're going to combine everything together. We'll
Hmm.
take that vial holder assembly and the hat assembly, and we're going to place it such that again the indent in that assembly should line up with the GPIO pins. Not that, the larger, yes, that's it. Yeah.
That one?
Yes. Oh, I'm forgetting something. Sorry. This is where sorry, I don't have the instructions
Ah,
in front.
we need
So
these
yes, we'll take these
stand-ups, right?
last nuts. Yes,
Cool.
these last nuts go on to the top of the hat. Yeah.
Cool.
Yeah. And then it should make sense.
Cool. There was also a request for 3D printer files. I think there's a lot of way, like it could minimize shipping, so the carbon cost and so on, and also let people, like, if I really didn't want to buy an Adafruit and I wanted to flip up one of those because I
Hmm.
wanted to look at it, we could develop our own. Is that something that's in the pipeline?
It is, yeah, yeah. We have a goal this year to open source as much as we can, including the 3D printer files, the design files, and the hardware, the hat, the electronics.
For the hat as well. Cool.
Still on track. We'll likely share things both on GitHub under our Pioreactor organization,
Hmm.
but also on Printables, which is
Oh, right.
Prusa
Cool.
design
Yeah.
sharing website. So look there for, I think we're at Pioreactor on Printables too. So look there for files coming in. Some of the things are easy to print, some things are harder to print because they
Mm.
require different plastics. But yeah, we do want to share those. We like there's just a lot of opportunity with like people changing the vial holder.
Yeah.
I want to see community contributions there.
So
I think that's very,
is it OpenSCAD or?
we don't know yet. We're not sure what
Oh,
our
right. Okay.
plan will be. Yeah, we're still like kind of iterating on designs. We want things to be kind of stable or more stable before we can
Mm.
share them. Yeah. Okay,
Sure.
so yeah, you're on the next step. So just using the 6 mm screws, you'll just attach those two pieces together.
Have I got lots of 6mm screws?
You should have
Yes,
8 there.
eight.
Yeah,
Yes.
you require 4 for this. Yeah.
Cool. And yeah, a bit of a niche request was whether it might be possible to control the temperature below ambient.
Yeah. We get this every so often. This request. Not yet. Like our solution has been to put it in a colder environment and then heat it up to the temperature you want. So we have last year as a demo, we put the Pioreactor in a cooler, and it was like one of the coldest days in December here in Canada, and left it outside plugged in, away from any kind of like liquid snow or anything, and it did great. We got from I think it was at like -3 ambient, and we raised it up to 10 degrees Celsius. So environments like
Cool.
that do work.
Yeah.
Uh, a built-in solution is more difficult. It's easy to heat things. It's really difficult to remove heat. That's kind of what
Yeah.
I've learned in this process. Uh,
Peltiers?
Possible. They're a bit of awkward though. They're awkwardly designed, like the actual like um, technology. If you
Mm.
compare Peltiers to PCBs, which is what we use for heating,
Yeah.
as a society, we're really good at designing and assembling and creating PCBs. We can create
Mm.
them from aluminum of any shape, of any size, any thickness. Peltiers, they're more awkward. They're like a set fixed design. Not as much interest in Peltier manufacturing versus heating
Yeah.
PCBs.
They're not very efficient either, I think. So.
That's right too. Yeah. There's that to contend with.
Cool.
Cool.
Right, I
Looks
think we're all
looks good.
attached.
Yeah.
I'm
Okay,
happy with that.
so we'll attach some of the wires next. So that stirring fan wire, we're going to attach to the label PMW channel 1. It's unlabeled, I should say, but we're going to attach it to PMW channel 1.
Oh,
It's
this
right
one
above
here.
button. Yes, yep, to the most.
And it goes clippy. Oh, clip side up. Yeah.
Yep,
So,
it's
like
polar, so it should fit. Yeah,
cool. Yep.
for partridge force. Great. And then on the other side, that heater PCB connector, you'll notice on the hat, there's a corresponding connector on that side. We're doing the same thing. This one's sort of difficult to get in, but with the right screwdriver, and you should be able to sort of seesaw it in. You'll understand what I mean.
Does that need to be right out before I start?
That looks out. That looks out like that. Yeah.
Is that sufficiently in?
Yes. Yep.
Okay, right, and then I clip that.
You may need a screwdriver for this one.
Oh yeah. Ah, this is the bit that's difficult, not the bit that I've just managed and thought I did really well. Okay. Yeah.
Yeah.
Cool.
Cool. Okay.
Excellent.
So the next step is to open up the LED bag, the LED and PD bag.
In this bag.
Yep. So
And
the
I've got some extra bits in here that I ordered.
some extra cables.
Not opening. Right. So I'll take those out just to avoid confusion, and then we can maybe use them later.
Yeah.
Those are the 2 extra ones. Right. Okay.
Okay, so first we're going to take the, let me see, what actually I suggest in my docs. First, we're going to use one of the black LEDs. These are actually
PD?
photodiodes or PDs.
Yeah. Cool.
We're going to plug it into where it says PD1. For viewers at home, it's hard to see, but like there's labels on this faceplate. So PD1.
Okay, the cable side, right. I was looking for a port. Right, PD1. Yeah, cool.
Yep. So you plug it in there. And then, let me do the same thing. So we're going to take that cable and stick it into the pocket on the vial holder labeled 90 degrees.
90, so all the way around the corner.
Yep. Put it in straight. And then we're going to, this is one of this is one of the rules you can break, and it's okay. You can now bend the leads. So you can just bend it 90 degrees towards, yep, just like that.
Oh, came out again.
It does that.
Okay.
While we're gonna actually open up the LED cap bag. Okay. We're gonna take those LED caps.
I should probably get another question as well. Yeah, so wall mounting, so that we could have like vertical Pioreactor farms, and also to help me so that I could like attach it to a tripod effectively here, and then I can talk to it during live streams. I've seen actually that that's probably going to be quite easy, because although I'm not seeing them now, where is the... So you have a system, a dovetail system?
We do.
Right?
Yeah, it's something like this. That the Pioreactor can
so it sits in that, right? So I need to, and that's already open source, right? So I can print myself one of those.
Yep.
Brilliant.
In fact, this dovetail system, it's actually a sort of open source protocol. It came from a different lab, the Dormant Bio Lab.
Yeah.
And they shared some initial designs, and they have like a whole suite of different lab tools that kind of use this dovetail design. We liked it so much that we wanted to use it for the Pioreactor, so it kind of fits into that dovetail ecosystem.
Open standard, cool.
Yeah.
So
So that LED cap
is it
should
just
fit.
any one of these? They're all the same.
They're all the same. Yep, they're all the
Yep.
same. And
So
it
that
should
goes in.
rotate. Yeah, if you rotate it, it should fit on. Yeah, it's a friction fit. Yep.
Yeah, that's in. Lovely.
Cool. So next we're going to use the, just need to look again. Okay, so next we're going to take the clear LED, which is the IR infrared LED, and we're going to plug that into channel A. So again,
Channel A.
on that
This one.
hat, or on the,
There?
should say A. Yep.
Got A there. Camera's not picking it up, but honestly, there we go. It does say A. It's in.
Okay, and that's going to go into the hole labeled IR.
Cool.
Cool.
Did I bend that again?
Bend that again and put on an LED cap.
Yep, that's on.
Great. And finally, the last black LED, the last photodiode.
Mm-hmm.
That goes into photodiode
PD2.
2. Did I? I hope I got that right.
Sorry?
Yeah, it's fine. Yeah, it's.
What's up?
I actually got them backwards, but we can change it later. It's not a
Oh,
big deal.
so do you want the first one in 2?
Yeah,
instead of
if
one?
it's easy to do. If not, we can always. It's a
Yeah.
soft configuration change too.
It's done.
Okay, great. Yeah.
Cool.
yeah.
Right, so the second one goes in 1.
Yes, that's right. Yeah.
But lost it. The bag broke its fall though. Okay,
And
and
this one's a little bit more awkward. It's going to go through that hole where the IR cable is. Let me see. Let me see if I can.
is it the 45
it's-
I'm aiming for?
It's going into ref, REF.
Oh,
Going into-
ref. Okay.
Yeah. But you want to position it. Let me see if I can. It kind of goes. Might be easier with a picture, but it kind of like reverses. Like it kind of goes. It kind of does a 180.
So it's going in there and bending backwards, yeah?
Bending backwards, yeah, bending towards the labeled X3 or away from
Yeah.
IR. Yeah.
Okay. Would this have been easier after the IR? I mean, before the IR.
Maybe it's certainly possible. You can remove the IR one and do it now that you kind of know it. It's fine.
I'll go for it. There we go.
Okay.
It's in? Cool.
And then so with the rest of the LED caps, just sort of go around the rest of the
Hold on.
bioreactor and put them in. There's one extra LED cap, I imagine. That's just a spare.
Cool. Right, more questions, hopefully. So, yeah, just on the sort of mental barriers to entry of, some people might... This is not difficult, despite me making it look difficult. It's not. But some people might prefer just to buy a whole ready constructed unit that's already got all the software installed and everything, and you just take it out the box and start your experiment. Is that something you're considering?
It is, yeah. We originally only had it as a kit, as you have here, and we like that. There's, I think, philosophical reasons why we like it as a kit. The user assembling it kind of makes them familiar with the ideas, helps them like error correct things, helps them like extend it. Easier to discuss with them because they know what like the PD is, they know what the stirring assembly is. However, we do want to sell like a complete one with the Raspberry Pi, with the SD card, with the software loaded, more like a very, very close to plug and play like system. You just plug it in, it should boot up, and you're good to go. Right now, we've just focused on the kit, but hopefully by the end of this year or early next year, we'll have an assembled version.
Cool. Brilliant.
So that looks good. So the last step is to put the window on. So there's a small plastic window.
Shiny side out or in?
Either, doesn't matter.
Okay.
Whatever looks visually best.
I'm gonna
And
put it's more than that.
the last 6mm screws will secure that.
Brilliant. And ultimately then with that also, I don't know if you saw the last show, I got a bit of a custom surprise with mine. Are you contemplating global stockists?
Yes, yeah. We get lots of international orders. We're based in Canada, so most orders happen to be international. And everyone would like to see, that more accessible, like buying it to be more accessible. So we are considering global resellers for the Pioreactor. We're going to trial it in Canada first, just to get our legs, our feet wet, excuse me, understanding the relationships, understanding the contracts and things like that, and then kind of expand. Probably to the UK next or the US next. Those are big markets for us. But it would really, really make things easier for everyone, for us, for the customer.
Yeah.
No one likes the big customs VAT surprise, right?
Yeah. Oh dear me, I'm making a picture out of this one. What is that? Got there eventually. Sorry, I keep...
All right, here we go.
I've got my
Yeah.
camera too far forward as well, so I keep pulling the thing back so you can't see it. And no doubt it's constantly going out of focus as well. Right, then... You've already answered this one. Sorry, what you said?
I can talk a bit about like why we started the Pioreactor.
Yeah.
Because like we have an interest in building this too. It's not just like our users want to use it. It was myself. I was getting interested in cellular agriculture, sort of like the clean meat movement. I think that's like really exciting. I really like it. But I was working in software. I was working as a data scientist in tech, and I wanted to get my feet wet in biology. I had a bit of biology experience from university, but then since, and my solution was to go to a local homebrew store and buy an Erlenmeyer flask, some yeast, some DME sugars.
Cool.
And it was literally like me in my closet growing yeast and sampling it and counting it out and doing like a growth curve. It felt like I was though Louis Pasteur in like the 1800s. It was very, very, very like archaic. And I was thinking, okay, what's the next step up? And it was going to be a bioreactor, which, as we kind of have seen before, they cost a lot of money. They're thousands of dollars a month. So we wanted to build something that was in between. So not the Erlenmeyer flask, not the massive bioreactor that has too many features and then there's too many like liabilities really with all those features. So we kind of designed something that was mid-market, that was simple. We could do research on, we could learn about biology, use like modern principles like the browser. The browser is actually like awesome, and we love the browser. We should use the browser to like display data.
Yeah.
Raspberry Pis are accessible. Like using Python is great because people can like hack on Python, build their own things on Python. So we want to sort of fit that niche market of a mid-market bioreactor, which hadn't existed.
Cool. Brilliant. So you did it.
So
Well
did
done.
you. That looked done. That's great.
Yeah.
So the vial can just fit right in now. The vial should sort of slide
I'm just
in.
thinking, this probably should have come before. I'm thinking about maybe some algae next. So I got these from Bitsbox, and these came in addition to the kit. What am I best doing with these?
Right. So the row of on the labels, it says A, B, C, D.
Yeah.
Each of those is a spot for a different LED. So we use one for the IR, and that's used for optical density. but you can plug in other LEDs. So yeah, go ahead and
Should I
plug
go
one in
B?
B and C, sure. Yep.
B and C, so I'm using two. Okay, cool.
Yep, we can do two. Uh,
Oh,
and
that just
then
bent.
yeah, that's okay. You can kind of just
That,
like bend it a
oh,
little
right,
bit.
okay.
Yeah.
Cool.
Yeah.
Yep.
Then we'll take your LEDs, and
Mhm.
the orientation is very important here. Don't have an
I got
example.
10 because they were cheaper that way. Right, yes, long leg, short leg.
Yes, long leg, short leg. So the long leg is positive, short leg is negative. So the on our cables, the cables we provide, um, the red line is positive. So we're gonna, yeah, you can put it in like that. So you can stick those in like so. You can trim them a bit if you want. That's fine as long as you still remember the orientation. Um, yeah, sure, something like that's fine.
Okay. It's not working. That one's not good. Oh,
Yeah, if it doesn't go in the first time, pull it out, put it back in.
the back one's sort of going out the back, which is a bit strange. It'll
Yeah,
still work.
it'll work.
It'll do
Yeah,
for now. Let's, yeah.
trim them later for
Yeah.
sure. Because we trim our LEDs when we make them. So those can be positioned anywhere. We kind of have two ideal spots for
Yeah.
visible light, X3 and X2, it's labeled.
Okay. Cool.
So those are, they don't, basically like each of those pockets is a little bit different. X3 and X2, they're wide angles. You can think of it that way. So those sort of
Yeah.
blow up the light. So kind of the same thing. Yeah, they go in. You can choose to put a cap on them or not. Probably want to put a cap on them, but yeah.
Ooh, that one doesn't want to bend. E. Hey, your ones are easier for bending.
Oh, yeah, possible.
I presume we want to keep going in a sort of clockwise direction, having them all.
Sure. Yeah.
Yeah. Oh yeah, trimming would make this easier.
Yeah, we should add that to the docs if we don't have it.
Sorry, I keep pulling it in to rest it against my chest, and then nobody can see it. There we go. Right, done.
Cool. Okay.
Excellent.
So later on, if we get the software going, we can kind of programmatically turn those on and off.
Brilliant.
Those additional LEDs. You can use, like, if later on, more advanced use cases, you can kind of like scale up the amount of visible light you're showing. Each of those channels, those LED channels, can be tuned between 0 and 100, 100 being their maximum brightness. So you can kind of like graduate your culture to higher intensities. You could think about like blue-green light LEDs to maximize like photosynthetic wavelengths. So lots of possibilities for adding LEDs. It's really starts getting fun when you add LEDs.
Cool. Brilliant. So next, that looks fully assembled, I think. Yeah?
Yeah, yep.
Yeah. So next is the software, I guess.
Yep.
Which, right. So, in terms of software, right, you can just, no, you can't, wait there. I'm on the wrong thing. Let me go. Right, software. This I did earlier. We'll see if I did it right. So anyway, if anyone actually wants a walkthrough of this, we can, well, I can practice lots and then we can do a proper walkthrough video, but this is just basically what I did. And I'm guessing that this goes in down the bottom with the copper facing up. Oh, you can't see that anymore because you're watching the...
Copper faces... Don't know. Copper faces up, yes.
Um, right, is there... We'll leave... So the final question was just around overflow, which you kind of addressed. So you don't think there's much risk having the liquid above your Raspberry Pi?
There definitely is a risk. There's a risk of like spilling beside the Pioreactor as well. We've taken that into consideration and tried to make both the hardware, the mechanical bits, and the software for sure prevent those mistakes. So the software, like if you try to overflow or if it senses something's wrong, it'll just stop. It'll stop and halt and say, hey, something's wrong, check it out.
So what happens if you have you're using this in, sorry, I'm going to go back to the other view now, hopefully. If you have this in chemostat mode, so you've got liquid going in, liquid coming out, how does it know that the liquid's actually coming out?
So there are a few like failure modes. Like if the waste pump just totally shuts off, it won't know. It's kind of a consequence of the pumps we use. In the software, though, it's tracking. It's saying like, okay, you've started with 14 milliliters, you've added 0.5. I'm going to remove 0.5 to make sure it's 14 milliliters again. If your algorithm goes outside some of those bounds, it'll
power this up while you're answering.
Is the SD card in? It sounds like it is.
Sorry, yeah. So I
yeah.
in there, copper side up.
Yep, great. So plug that in.
It went in easily the first time. There we go. Right. So now power. I've got the official Raspberry Pi one. I think you said that was.
Yeah.
I've also got a little USB-C there. You wouldn't advise me connecting from that in. You'd prefer that I use.
I would. In
that's a 4.5 amp.
Use the official one. We don't advise using like phone chargers. Those are pretty. Those also provide like 5 volts, but not enough amps. That one might be okay. The one you have there, it's 4.5, might be enough. I don't know how that's distributed though.
Where's the blue light I'm looking for?
So, no, that's good. That's good. Yeah. The red light's on, which means power is being supplied. I believe I saw a green light for a second, which is also
that one. Yeah.
Yep. Now it'll take a minute to kind of boot and kind of like configure itself. And eventually you'll see a blue light on the hat start flashing. It'll take.
Is that one?
It'll be near the button, yeah.
Near this?
Yes,
oh, there we go. It's flashing. I see it flashing. Hooray!
Cool. Okay.
Excellent.
So that should be ready then. We can try one of these.
I'm going to need to put it into our Ethernet as well. Should I have done that before I powered it up?
I don't know. I think it should still be okay, but you're kind of testing new things here.
I'm going to give up with this now. Right, there we go. So that's going. And so we should be able to then go to Pioreactor local, which...
Try let's see the URL again. So Pioreactor, it's served over HTTP and not HTTPS. So let's try explicitly putting in HTTP
/ enter.
Not yet. Yeah, maybe give it a moment. Maybe the Ethernet should have been plugged in before we turned it on.
Should I just power cycle it now then?
Yeah, let's just try that.
Is that just done by unplugging it?
That's fine. Yeah.
We're unplugged. We're plugged in again.
And if you see the blue flashes, we should be online.
We're all looking for the blue flashes.
This has always been the most difficult part of the engineering
Yeah.
process. There, you know, thousands of
Networks.
iterations and permutations of Wi-Fi networks and Ethernet networks. So we always pray to the network god for things to work here. Okay,
Blue
so blue
flashes?
light. Yeah.
Okay.
So go to
Connection's timed out. Okay, let's try again then.
the other thing to try.
Mm-hmm.
Your host name was PIO00.
Where was that?
That was in your, like you named it that.
Oh,
in your
PIO001. Yeah.
001. Okay, so try HTTP PIO001.local.
http:// PIO001 dot
Dot
local.
Yeah.
Hey!
Cool. Okay.
Oh, I'm excited. Sorry.
Yeah, we'll figure out the other thing later.
Cool. So is there anything we should do in this?
I mean, you can kind of like, yeah, maybe make it a bit larger. One thing just to like make sure, things are kind of like working.
Yeah.
First, like if you go back to the hardware, there's a button on it. If you press that button on the screen, you should see something come up.
Okay, so the button, that's this button here.
Yeah, yeah. And so if you hold that,
Okay, I want to look at this. Oh, I am looking at the screen. Am I looking at the screen? No, I'm not looking at the screen. I'm now looking at the screen. I'm holding that button. Ah, look
Cool.
at that. I
There you
love
go.
these things. That's just so cool.
people love buttons, right? Yeah. So I mean, you might ask like, what is this for? And if you have like 3 or 4 Pioreactors in front of you, you kind of want to know, okay, who's in front? Who is this? It's a quick way to identify them.
That's brilliant.
The next thing, next most important thing is if we go to the hamburger menu in the top left
Yep.
and go to Pioreactors.
Pioreactors. Yeah.
And here you will, if you had more than one Pioreactor, you could see them all. Right now we just have one. We can click identify, and that's kind of the inverse operation.
Okay. Yeah. So that
It'll link
is.
your Pioreactor.
It's now. Right. I'll do that again. Identifying it's flashing.
So again, it's kind of like, which one is this? Who made that? Who am I working with? Okay.
Cool.
So back in the UI, we want to do a self-test. A self-test is really important to make sure things are working.
Do I want to be, when I press that, do I want to immediately go to the, to see it physically?
No, it's not very interesting physically.
Okay, right. So self-test here.
So you can run that. You can hit start. Some might fail because I do mention we should put water in it. That's okay. We can do that. You can do it later.
I have some
But
water.
anyways, the point of the self-test is to test all the hardware. So tests the LEDs and photodiodes, make sure that they have like a proper relationship. Test the stirring, test the heating, test the RPM detection. A few other like minor details, but this is just a good diagnostic test to be like, yes, okay, I feel confident. Pioreactor is sensing things, is responding to things. So this takes, I think, 3 minutes or something to run.
Okay. Well, I've put some water in, and it did light up. I saw it lighting up inside. ADC reader encountered an error.
3.3. Try running it again. It might have been just because like when you put the glass in,
Yeah,
it kind of made a reflection that
I
was.
took it out as well.
Yeah.
So
But yeah,
the
this is why
vial was out when the light went on.
You want to like check to make sure things work.
Mm. Cool. So, yeah, let's talk bugs then, since
Okay.
you're into well, while we wait for this, um, you're into meat culturing, right? Have you managed any of that so far, or?
No, no, like that's what got me into biology. But I kind of diverged. I got really interested in yeast. That's interesting. Let's see what's going on there. Um, oh, you know what's happening? I'm just thinking.
Is
I'm
it my
gonna, I'm
extra
gonna
LEDs or something?
look at the geometry here. IR90 X3. Yeah, it's the extra LEDs.
I'll just get rid of those for now.
Yeah, yeah, just unplug
Yeah.
them. This is something that we should kind
Okay.
of think about. Yeah.
So that.
What
Oh,
was
is
happening?
it that you wouldn't expect the self test to work with extra LEDs in?
Yeah, yeah. The one of your white lights, it's white light, but there's also lots of IR
Hmm.
light, and it was shining directly across into the 90-degree
Ah,
photodiode.
okay, right.
And so it was like, whoa, there's way too much light here. Something's wrong.
So we need to have them staggered so that it's measuring at one time, but the LED isn't on. Is that
So
right?
normal, yeah, in normal operation, you'll do an optical density reading every n seconds.
Hmm.
During that time, when you're taking that reading, it shuts off all the other LEDs except for the IR one. Um,
So it just
so
automatically does that. I don't need to program it.
yeah, yeah, that's baked in,
Okay,
kind
cool.
of to avoid the problem, right?
Except for the
So
self test.
except for the self test, I think it has the assumption that there's not going to be other
Right.
LEDs.
Yeah.
I'm gonna write this down because that's kind of interesting. How do we support that? But yeah, so go back to your question about like culturing meat. Like we got more interested in yeast and bacteria
Hmm.
and algae. The meat stuff is cool. Uh, I don't know if you can grow like mammalian cultures in our vials.
No.
Much more constraints on mammalian cultures around like pH and CO2 and oxygen. Even though they're very fragile, right? So you can't really stir them with a stir
Yeah.
bar.
Yeah.
Um, so no, we haven't really like done much mammalian cells.
Right.
Cool. So we're getting green check
Yeah.
marks. It's a
Cool.
good sign. So that was definitely the problem. Um, Lots of green. That's what I like to
Oh,
see. Okay,
warning.
so probably I would imagine. Let's see. We'll wait till it finishes.
Oh, it's
Uh,
moving now.
is it making that sound? Do I hear it? Yeah.
Yeah.
So Martin, I think what's happening is like
Oh, it's making it faster.
yeah, I think you're still. If I look at my model. Still like too little of a gap between these.
Okay.
Yeah. So I would
Shall I stop it before it hurts
no,
itself?
it's
No?
fine. It's just like this noise won't happen in practice. It's just because it's hitting the
Yeah.
um, what's it called? The screws above it. So
Right. Okay, I'll fix that later.
yeah, yeah. So just solve that, and we have like docs on this too. You just want to add a bit more of a gap here.
By loosening the
It,
screws.
yeah, by loosening the metal screws that connect the stirring assembly to the file folder.
Mm.
Um, yeah, there's docs on this. Uh, should be very clear. Yeah, but so I imagine some of these tests should fail because of that, or not. Maybe we'll see. They should. Terrifying sound.
Isn't it? It's feeding back through your mic as well.
Oh, yeah.
Yeah.
Yeah. But
Scary stuff.
it's silent operation. I
Yeah.
swear. It's just like a bit of grinding going on. It's harmless though.
So then, other than the sort of cell ag, we've got what I would describe as precision fermentation and biomass fermentation. Have you? What are you? So to me, precision fermentation is when you're actually using gene editing in order to have microbes produce whatever chemical you want them to produce. And then biomass fermentation to me is when you're just producing those microbes and then maybe drying them and eating the whole microbe. Have you done either of those?
No, mostly due to like, I mean, the biomass one is much simpler. It just involves sort of growing it and drying it. We don't consume any of our microbes just because we're working with like baker's yeast. It's not very interesting to think about or consume. The precision fermentation is really interesting though. We haven't done it, but in theory you could. It's just, growing cultures and then kind of like extracting the protein or the molecule of interest afterward, the metabolite of interest afterwards. Of course, that can be done. We're just in the business of growing things. So this is interesting. It should have stopped by now. I think it's kind of in a weird loop.
Okay.
Trying to think of why it's in that loop.
Is there a way to stop it?
Is there a way to stop it? Yes.
Oh,
hit
it's
exit.
going even faster. It's going to take off. Just hit what, sorry?
Hit the X there. Yeah. And then there should be like
Yeah, and it stopped.
It stopped. Okay.
Right.
So yeah, it got scared, I guess.
Okay.
If you open up self-test again, I wonder what it resulted, how it
Oh. It started again. I'm sure that was before I hit self-test.
Yeah. Strange. Okay. Sorry. Let's close this again.
Maybe it wasn't. Maybe. Right. Anyway, I'll check on the replay.
Yeah. Something we'll talk about it after, but so
We've got a brilliant. I know that series. I didn't touch anything there. It started.
No.
We've got like a great comment from Garrett as well. He's saying this is going to be a great resource for assembling bioreactors. Wouldn't have been that useful if everything went great the first try.
Yeah. Martin, is there a stop all activity in your UI that you can see? You scroll up a bit.
Oh
no, from this page.
Stop all activity.
Stop all activity, and we can sort of deal with that later.
How immediate should that be?
Like pretty within a few seconds.
It's slowing. It's now silent.
Yeah. Cool. Okay. Yeah, definitely like off stream for sure. Like loosen up those screws a little bit.
Yeah.
Yeah, and I think we'll make the reporting around that a bit better. That like, hey, something's wrong here. Investigate this bit.
Brilliant. So, right, let's see. Oh. No, this is... There we go. Right. Where are we now? So... Right, the intention. Let me just get my slides up for a second. So yeah, the intention is that I'll be back here at the same time, 8 p.m. UTC next week. The intention is not that it'll be an hour and 10 minutes as we have been this evening, but that was, I found it very interesting. I hope you guys did too. So yeah, and next week hopefully I'll actually be using the Pioreactor, starting some culture. So please, yeah, do subscribe, ring the bell so that you can join us live, or indeed let me know if 8 p.m. UTC on Wednesdays doesn't work for you. And please, yeah, do let us know your thoughts in the comments. Are there any features that you'd like to see in the Pioreactor, or do you have any questions on either setting up your own or perhaps setting up a digital twin so that you can do virtual experiments in the safety of your own laptop? So yeah, thank you very, very much. Cam, thanks for joining us. Thanks also a lot for actually making the Pioreactor and going for it and getting it done. I'm in awe. It's brilliant.
Cool. For having me.
And yeah, thanks to everyone for watching as well, for taking the time. Yeah, together we can democratize food. See you next week.